Hello there and welcome to my video on drawing quadratic functions from their axis intercepts. So in this scenario, you've got a quadratic function here. We're told that each of these is a quadratic function, and we want to sketch them. And the reason is normally you just want to get an idea about what this quadratic actually looks like. It's fair enough for me to say, oh, there's a quadratic. Here are its x-intercepts, this is its y-intercept, but how do you visualize and get a gut feeling for what a quadratic looks like? Well, to do that, we will sketch the graph. Let's start with the x-intercepts. Notice that they are -6 and +2. Remember that the x-intercepts are where the function crosses the x-axis, and it crosses at -1, 2, 3, 4, 5, 6. X equals -6 is one of the axis x-intercepts, and the other one is at +2. 1, 2. Bam! The y-intercept is at -2, so I go down 1, 2, and there's the y-intercept. Notice that the y-intercept is on the vertical axis, the y-axis. And we can label this one as well. So because it's a sketch, it's important for me to put a dot at the important points, which are the x-intercepts, the y-intercept, and to label them as well. Now, we know this is going to be a parabola, which is like a smiley shape face. Smiley shape face? Yes, smiley face shape. And we know it's going to be a parabola because all quadratics make a parabola. But how do we sketch it? Like, does it look like this? Or, oopsie, that's not a very good one. Or does it look like this? That's not a very good one. How can we draw it in a nice, neat way? Well, one tip that I have is imagine a vertical line that is halfway between the x-intercepts. Let's find the point. There's the x-intercept and there's the x-intercept. So just imagine the point that is exactly halfway, which is this point here. Now this point is 1, 2, 3, 4 units away from here, and it's 1, 2, 3, 4 units away from that x-intercept. So it's halfway between them. I want you to imagine with your brain a vertical line right there. You can even draw it as a dotted line using a ruler, obviously. And the reason I've asked you to do this is because all parabolas are symmetric. So the parabola will be like a mirror image around this vertical line. And also, the turning point will be on the line. So the turning point will be about here. It will look like this. So do you notice that this is the left-hand side is the same as the right-hand side, but a mirror image, and it goes through the points. Yes, symmetric, parabola, beautiful, good. Let's try another one. This one is a little bit different. How do you think it is different? Look, the x-intercept is at 1. X-intercept of 1 is here. But where's the other x-intercept? This thing only has one x-intercept. And if there is only one x-intercept, that means it can't do something like this. Whee! It can't do that because then there would be 2 x-intercepts. And we're told that the only x-intercept is at x equals 1. Therefore, if there is only one x-intercept, you know that it has to touch the x-axis and turn back around. That is a terrible diagram. It has to touch the x-axis and turn back around. So you'll always have one y-intercept. In this case, I've put it on at -4, so I go to my y-axis, which is here. -4 down, 1, 2, 3, 4. So I put a dot there. But the thing that might be different is maybe you have 2 x-intercepts like this. Maybe you have 1 x-intercept like this. Or maybe you have none at all, which is complicated. So if you only have 1 intercept, you know that that is going to be the turning point. It's going to touch that x-intercept, just touch it. It won't go through it, it won't cut it, it'll just touch it, and it will turn back around. And of course, all parabolas are symmetric, so if it makes it easier for you, what you can do is you can draw a dotted line at that x-intercept and know that the parabola is symmetric around that line. It's a mirror image around that line, because that might make it easier to draw. All right, I hope this has been helpful to help you get an idea about what quadratics look like. Next up, we'll plot some different quadratics. So you'll be able to look at a quadratic equation and bam, in your head, you'll just be able to see it like you're in the Matrix, which is very cool. All right, until next time, everyone, bye.